model the working on the human brain. Okay, so model the working of the human brain. So just a model of the human brain. It is more computational model used to perform tasks in a better optimized way than a traditional systems. More computational model. The essential properties of the biological neural networks are considered in order to understand the information processing tasks. The information processing tasks. So this is the basic concept, of course. So now we know about the what is the introduction to this artificial network. Introduction to artificial network. How the artificial network, the main principle we discussed, the concept here, but artificial network is an simply it is an information processing system. Technically, as per the technical discussion, it is an information processing system, and on that information processing system, it has possesses some characteristics of the biological neural network. The word biological plays a lot of role. A biological neural network. So artificial neural network consists of a large number of highly interconnected processing channels. Okay, called nodes. Okay, so are units, or you can call neurons. The neurons, nodes, units are the key. All are the keywords. Okay, there are consists of highly interconnecting processing neurons. Also, it consists of. Okay, so artificial neural network is an information processing system. It is simply an information processing system. We simply call it as an information processing system. You can call this one as artificial neural network is an information processing system. Okay, so in this information, it consists of a large number of highly interconnected processing channel elements. Okay, a large number of interconnected processing channels elements, it will be connected. They are called neurons. Simply it is called a neurons. Okay, so there that is a communication link exists with assigned weights, which consists of information about the input signal. Okay, so it consists of the neurons operate in parallel. That's the most important. These neurons will operate in parallel. It's a parallel connection is exist in the neuron. Every neuron is connected to the other neuron through the communication link. One neuron is connected to other neuron through a communication link with assigned weights. With assigned weights. With assigned weights. Okay, so which contains information about the input signal. Which contains information about the input signal. So one neuron is connected to other neuron with the help of communication link. These neurons operate in a parallel processing. It's a parallel. This consists of a parallel connection. So the most important one is these neurons operate in parallel. These neurons operate in parallel. These neurons operate in parallel. So every neuron is connected to the other neuron through communication link. Okay, every neuron is connected to the other neuron through the communication link with a assigned weight, which consists of information about the input signal. Every neuron is connected to other neuron through the communication link. One neuron is connected to other neuron through a communication link. Of course, it is a parallel processing. So it consists of a communication link. Okay. It's a communication link. Just 1 minute. The processing elements are called neurons or artificial neuron. These processing elements is called as neurons or artificial neurons. That's the most important one. So these processing elements is called as neurons or artificial neurons. Okay, so they are called the processing elements, of course. Okay, so the biological neurons consists of three major parts. The biological neurons consists of hello. Schedule already started Amma. Okay, it's already started, right, Amma? Thank you. The biological neuron consists of three major parts. Okay, so what are the three major parts is very important. the fact that human brain consists of large number of neurons. So when you take a human brain, it consists of large number of neurons with numerous interconnections that process information. Okay, the term neural network is usually referred to as biological neural network. Okay, that processes and transmits information. Okay, that process and transmits the information. Okay, so this is very important. This is very important actually. Okay, then we will discuss about the biological neuron system, nervous system. Okay, so we are stressing here the medical science also. The most of the important points in the medical science actually. Okay, the fact that the human brain consists of a large number of neurons with numerous interconnections that process information. The term neural network is usually referred to the biological neural network that processes and transmits information. That process and transmits the information. Biological neuron consists of three major parts. Biological neurons consists of three major parts actually. Okay, so this biological neurons is a part of nervous system. In nervous systems, a major part is biological neuron. The biological neuron consists of three major parts. Okay, soma or cell body. Here I am discussing biological neurons. Biological neurons consists of three major parts. Biological neurons consists of three major parts, of course. Okay, one is soma or cell body. First, I will discuss are the soma or the cell body. The first part is soma or the cell body. So, contains the cell nucleus. In general, processing occurs here. Okay, it consists of cell nucleus. In general, processing occurs here. So, here I am telling all the in-depth concepts different than others because I am in the research oriented, practical oriented line now. So as a research concerned with a director, I am telling more practical oriented points. You should work more. Okay, you can think logically. You can interpret all these points. Okay, so then only you can acquire the more knowledge. Okay, so and the second part is dendrites. Okay, the other part is we are coming to the medical science actually. This is the other part. Okay, so branching fibers, the from the cell body or soma, it's connected to, related to soma, of course. The nerve is connected to the cell body. Nerves are connected to cell body. Axon, axon, axon. It carries impulses of neuron. It carries information away from the soma to the other neurons. Okay, axon. So the next one is synapse. So each synapse, the other part of the in the nervous system. Each each stand an axon terminates into a small bulb like organ called synapse. It is through synapse the neuron introduces its signal to other neurons. Working of the neuron. So then the working of the neuron. So dendrites receive activation signal from other neurons, which is the internal state of every neuron. That is the most important first point. The second point is soma process the incoming activity of the signals and convert to into output activation signals. Okay. The third point, axon carries signals from the neurons and sends to the other neurons. The axon carries the signals from the neuron and send it to the other neurons. So fourth point, electric impulses are passed between the synapses and dendrites. The signal transmission involves a chemical process. Signal transmission always involves the chemical process called neurotransmitters. It is called neurotransmitters. Okay, human brain versus artificial network. So comparison between the biological and artificial neurons based on the following criteria. So human brain versus artificial neural network. What are the points we have to cover? Okay, human brain versus artificial neural network. Okay, what are the points it will occur? So comparison between the biological and artificial neurons based on the following criteria. Okay, so speed. The first point is speed. Human brain versus our artificial network. Artificial data network is designed by us, okay, based on the human brain. Okay, speed. Signals in human brains move at a speed dependent on the nerve impulse. The biological neuron is a slow in processing when compared to the artificial neural networks, which are modeled a process faster. Signals in human brain move at a speed depending on the nerve impulses. The biological neuron is slow in processing as compared to the artificial neural network, which are modeled to a process faster. When compared to artificial network, that speed is very less. Okay, so human brain speed is processing. The biological neuron can perform massive parallel operations simultaneously. A large number of simple units are organized to solve problems independently. Okay, so the biological neurons can perform massive parallel operations simultaneously. So a large number of simple units are organized to solve problems independently but collectively. The artificial neurons also respond in parallel but not to execute programmed instructions. Okay, so this is a processing, parallel processing, of course. Simple one is a parallel processing. This a parallel processing concept will come into the picture. Okay, so size and complexity. The size and complexity. The next point, important point is size and complexity. Size and complexity. The size and complexity of the brain is comparatively higher than that of artificial neural network. The size and complexity of artificial neural network is different from different applications. Depends on application, of course. Storage capacity. Storage capacity. The biological neuron stores the information in its interconnection, and in artificial neuron is stored in memory locations. Biological neuron stores in the information in its interconnection, and in artificial neuron is stored in memory locations. Actually, okay. So the tolerance. Tolerance. The biological neuron has fault tolerance capability, but the artificial neuron has no tolerant capability. Biological neurons consider so redundancies. Then artificial neurons cannot consider redundancies. So control mechanism. There is no control unit to monitor the information processed in the network in biological neural network, whereas in artificial neurons model all activities are continuously monitored by control unit. Okay, so for next the important one is characteristics of artificial neural networks. That is an important module. Okay, that is very important conceptual oriented module, of course. Okay, so characteristics of artificial neural network. It's a the first point is here is we want to highlight that it's a mathematical model consists of computational elements implemented neurally. That's the first point. The second point is large number of highly interconnected processing elements known as neurons are prominent in artificial neural network. Okay, large number of highly interconnected processing elements known as neurons are interconnected in artificial neural network. Okay, the third point, the interconnection with their weights are associated with neurons. The interconnection with their weights are associated with neurons. The next, the fourth point is the input signals arrive at processing elements through connections and weights. Input signals arrive at the processing elements through connections and weights. So, artificial neural networks' collective behavior is characterized by their ability to learn, recall, and generalize it from given data. Okay, generalize it from given data. A single neuron carries no specific information. Once again, we're treating the characteristics. It's a mathematical model, consists of computational elements implemented neurally. The second point is large number of elements known as neurons are prominent to artificial, and third point is the interconnection with their weights and are associated with neurons. The fourth point is input signals arrive at the processing elements through connections and weights. So the fifth point is artificial neural networks collective behavior is characterized by their ability to learn, recall, and generalize it from given data. The sixth point is a single neuron carries no specific information. How simple a neuron network will work? Okay, so a simple neural network is the to architecture a simple neural network. So that means there are two input neurons transmitting. I will show the my presentation to you here. Just I will share my screen. Just see that how they are working. How simple neural network will work. Just see the diagram. Small x1, x2, observe the diagram, capital X1 and x2, corresponding weights, small w1 and w2, and capital Y is the summation here. It's a simple architecture of a simple neural network. So, from the given figure, there are two input networks, x1 and x2 transmitting signal to output neuron, Y for receiving signal. The input neurons are connected to the output neurons over a weight connected links W1 and W2. For above neuron network architecture, the net input to be calculated y of n is equal to like that. Corresponding weights you can multiply here x1 w1, x2 w2. The corresponding weights we have to multiply. Where x1 and x2 are activations of the input neurons, capital X1 and x2. The output yn is the output neuron. Y can be obtained by applying the activations over the net input. Okay, this is the output function. Basic models of artificial neural network. Okay, the models of artificial neural network is specified by three basic entities. What are three basic entities of the artificial neural network specified? The one is the models, synaptic interconnections. The other one is learning rules adapted for updating and adjusting the connection weights. The last one is activation functions. Okay, the model's synaptic interconnections. Artificial neural network consists of a set of highly interconnected neurons through the weights to the other processing elements to itself. The arrangements of these processing elements and geometry of their interconnections are important for artificial neural network. The arrangements of neurons to form layers and connection patterns formed within and between layers is called new network architecture. Okay, this is very important point. The arrangement of the processing elements in the geometry. Okay, interconnections are important. The arrangements of neurons from layers. Okay, the arrangements of neurons from layers connections. Okay, and within the between the layers. Okay, is nothing but network architecture. This implies a network architecture. This implies a network architecture. That is most important now. Okay, that implies a network architecture. There are five basic neuron connections in the architectures. Okay, single layer feed forward network. The second one is multi-layer feed forward network. The third one is single node within with its own feedback. The fourth one is single layer recurrent network. Fifth one is multi-layer recurrent network. Okay. Single layer feed forward network. We will discuss one by one. It consists of single layer network. Okay. Where the inputs are directly connected to the output. One per node with a series of various signals. In a multi-layer feed forward network, I will show the diagrams of course. It consists of multi-layers where along with the input and output layers, there are hidden layers. There can be zero to many hidden layers. The hidden layers is usually internal to the network and no direct contacts within the environment. This is the model designed for the single layer feed network. Just observe the diagram first. This is the basic concept of the diagram. In the multi-layer feedback network, just examine the diagram. Next one is single node with its feedback. The simplest neural network giving feedback to itself a single neuron. It's a single neuron feedback. One input and feedback. A single layer recurrent network. A single layer network with a feedback directed to itself or other processing elements are both. Multi-layer recurrent network. A recurrent network has at least feedback in place. The processing element's output can be directed back to the nodes to previous layers. Just observe, examine this diagram. This is the architecture. The most important part of artificial neural network, its capability to train its land. It is basically processed by means of which neural net adapts for adjusting or updating the connections in order to receive desired response. Learning artificial neural network is broadly classified into three categories. The learning of artificial neural network is three categories. One is supervised learning, the other one is unsupervised learning, the third one is reinforcement learning. Supervised learning. What is the supervised learning? In supervised learning, it is assumed that correct target output values are known for each input pattern. In this learning, a supervisor or a teacher it needs to error minimization. The difference between the actual and desired output vector is minimized using the error signal by adjusting the weights until the actual output matches the desired actual output matches with the desired output. This is the in unsupervised learning. In unsupervised learning, the learning is performed without the help of a teacher or a supervisor. In the learning process, the input vector of similar type are grouped together to form clusters. The desired output is not given to the network. The system learns on its own with input patterns. Reinforcement learning is a form of supervised learning as a network receives feedback from its environment. Here, the supervisor does not present the desired output but learns through critic information. Activation function. An activation function F is applied over the input to calculate the output of an artificial neural network. The choice of activation functions depends on the type of the problem to be solved by the network. The most common functions are identity function. It is similar. It is a linear function. It is defined f of x is equal to x for all x. Binary step function. This function can be defined as f of x is equal to 1 if x greater than or equal to 0. F of x is equal to 0 if x less than 0. Here theta represents the threshold value. Bipolar step function. The function can be calculated as f of x is equal to 1 if x greater than or equal to theta. Minus 1 if x less than theta. Here theta represents the threshold value. Sigmoidal function. These functions are used to back propagation nets. There are two types. Binary sigmoid function is known as unipolar sigmoid function. It is defined by the equation f of x is equal to 1 by 1 plus e power minus lambda x. Lambda is the steepness parameter. The range sigmoid function is from 0 to 1. The range of sigmoid function is 0 to 1. Mathematical analysis. This one is bipolar sigmoid function. This function is defined as f of x is equal to 1 minus e power minus lambda x by 1 plus e power minus lambda x. Here, lambda is the steepness parameter. The range of sigmoid function is from minus 1 to plus 1. The ramp function. The ramp function is defined as f of x is equal to 1 if x greater than 1. F of x is equal to x if 0 less than or equal to x less than or equal to 1. 0 if x less than 0. Graphical representation is shown in the activation functions like this. Just see the graphicals. Identity function, binary step function, bipolar step function, binary sigmoidal function, bipolar sigmoidal function, ramp function. Terminologies of artificial neural network. Weights. The first point in terminologies in that concerned with artificial network terminologies, the first point is weights. Weight is a parameter which contains information about the information is used by the net to solve problem. In artificial neural network architecture, every neuron is connected to the other neuron by means of directed communication link, and every link is associated with weights. Wij is the weight from processing element I, source code, to processing element J, destination code. The bias is a constant value included in the network. It is in fact seen is calculating the input. The bias included by adding component x not equal to 1 to the input vector capital X. Bias can be positive or negative. It may be positive or negative. The positive bias helps in increasing the net input of the network. Negative bias helps in decreasing the net input of the network. Threshold value is represented as theta. The threshold is a set value used in activation function. In artificial neural network, based on the threshold value, the activation functions are defined and output is calculated. Learning rate alpha. The learning rate is used to control the amount of weight adjustments to each step of learning. The learning rate ranges from 0 to 1. It determines the rate of learning at each time step. MP neuron model was the earliest neural network model. Okay, the MP neural is connected by the direct weighted paths. The activation of this model is binary. The weights associated with communication links may be excitatory, weight is positive, inhibitory, weight is negative. Okay, here the two conditions are there. Weight is positive, weight is negative, like that. Each neuron has a fixed threshold, and if the net input to the neuron is greater than the threshold, then the neuron fires, otherwise, it will not fire. Again, I am repeating the logic. Each neuron has a threshold. If the net input neuron is greater than threshold, then neuron fires. Okay, greater than threshold value, then the neuron fires. Concepts of linear separability. The concept set of point in 2D space are linearly separable if the points can be separated by a straight line. In artificial neural network, linear separability is the concept where the separation is based on the network response being positive or negative. A decision line drawn to separate positive or negative responses. See the decision line. The decision line is called as separatable line. The linear separability of the network is based on the decision boundary line. If there exists weights for which training the data has to response +1 positive, it will lie on one side of the decision boundary line and all other data on the other side of the boundary line. This is known as line separability. One side of the decision line and other side of the decision lines. Okay. Then HEBB network. Okay, a rule started by the HBB network explaining further. Here very important one is when an action of cell A is near through excite cell B and repeatedly takes place in firing in it, some growth or metabolic changes takes place in or one or both cells such that A's efficiency is one of the cells firing B is increased. In HEBB learning, if two interconnected neurons are on simultaneously, the weights associated with these neurons can be increased by changing the strength in synaptic gap, the weight update is given by weight nu is equal to weight volt plus some function. Okay, flow chart. Just observe this flow chart very clearly. Flow chart of the training algorithm. These are all algorithms which are used in the artificial intelligence. So, for purpose of neurons. Okay, so how the neurons are connected from one node to other. Okay, so those setup We will take a model of human brain only, but artificial neural network speed is high when compared to the human brain. Here, how the which algorithms are suited for this? Okay, so the flowchart pointing to that start, initialize the weights for each. Okay, if condition is true, no, what happened? If condition is yes, what happened? Okay, activate inputs. Okay, activate outputs, weight updates, bias update, stop. Okay, perception networks are single layer feed networks. They are the simplest perception consists of three units: input unit, sensor unit, hidden unit, associator unit, and output unit, response unit. The input units are connected to the hidden units with fixed weights values. It consists of fixed weight values assigned in random. The binary activation function is used to input and hidden unit. The response unit has an activation of 1, comma 0, comma or minus 1. The output signal sent from the hidden unit to the output unit are binary. The output of the perception network. Just examine the diagram corresponding weights, inputs, and output. All weights you can observe. Here only the basic diagram is input to corresponding weights and how the output will come, how the multiplications will come. Okay. The training of perception is supervised learning algorithm. Okay, supervised algorithm support is needed now. So all these concepts, so algorithm support is needed. So for that I am highlighted one type of algorithm previously. Now other type of algorithm is perception learning algorithm. The training of perception is a supervised learning algorithm. The algorithm can use it for either bipolar or binary input vectors, fixed threshold, and variable bias. The output is obtained by applying the activation function over the calculated net input. The weights are adjusted to minimize errors when the output does not match the desired. Okay, output does not match the desired output. Adaptive linear neuron. It's a neuron with a single linear unit. The linear activation functions called linear units. In this, the input-output relationship is linear. Okay, the adaptive networks are trained using the delta rule. So, is a single unit neuron. Adaline is a single unit neuron which receives input from several units and also from one unit called bias. Adaline consists of trainable weights. The inputs are two values, plus 1 or minus 1. The weights have signs positive or negative. Initially, random weights are assigned. The net input calculated is applied to a quantizer transfer function. Okay, that restores the output plus 1 or minus 1. Adaline model compares the actual output with the target in output and with bias and the adjustable weights. Okay, the other type of algorithm is training algorithm. So, Adaline network consists of training algorithm is as follows: weight and bias are said to be some random values. Okay, the random values but not zero. Set the learning rate parameter alpha. Perform 2 to 6 stopping conditions false. Perform 3 to 5 bipolars. Set activation for inputs I is equal to 1 to n. Calculate the net input to the output. Update the weights bias. The highest weight changes occurred during the training is smaller than a specified tolerance, then stops the training process. Else continue. This is the test for stopping condition of a network. Testing algorithm. It is very essential to perform the testing of a network that has been trained. When the training has been completed, the Adaline can be used to classify the input patterns. A step function is used to test performance of the network. The procedure Adaline network as follows: step 0, initialize the weights. Step 1, Step 1, perform steps 2 to 4. Bipolar input vector x. Set activation of the input value to x. Okay, so calculate the net input. Apply the activation function over the net input calculated. Multiple adaptive linear neurons, medallions. It consists of many medallions in parallel. Okay, with a single output unit. Okay, like that. It's architecture. Just see the architecture diagram. I want to stop here with this architecture medallion layer. These are all related to artificial neural networks. Okay, here you see the review questions before my conclusion. These are the define the term. This is the sequence of learning. Define the term artificial neural network. Define the term artificial neural network. List and explain. If you know the sequence, automatically you can main components of biological neuron. List and explain main components of biological neuron. Mention the characteristics of artificial neural network. This is the sequence of learning. Mention the characteristics of artificial neural. If you understand, my presentation is definitely different than others because I'm in association with scientists and in the industry people. That's why the reason I given all the sequence, okay, in a more clear manner. If you see these questions, you understand about my sequence of presentation. Comparison between similarities, differences between the neuron. Next is comparison between biological and artificial neuron. Differences between biological and artificial neuron. What are the basic models of artificial neural network? List and explain commonly used activational functions. If you understand these questions, you understand my presentation, greatness and sequence. This is the sequence. What I am giving the questions is the sequence of presentation. Okay, and very simple thing is define the following one: weights, bias, threshold, and learning rate. That's very simple. Weights, bias, threshold, and learning rate. Okay, and the next one is state the training algorithm. State the training algorithm for the HEBB learning networks. This is the sequence. Okay, if you understand this, this is enough. Okay, so I want to stop here. Okay, I will continue in the next session. This is enough. Please train up with these questions. Do the repetitive practice on this. Okay, how much practice as possible. Okay, so I will continue in the next class. Thank you all. Thank you.